Hello everyone. Welcome to the lecture series of partial differential equation. This is the second lecture in this series. In this lecture, we're going to discuss the formation of PDE. Formation of partial differential equation by elimination of arbitrary functions. As in the last lecture, we have done the formation of PDE by elimination of arbitrary constants. Here we are going to eliminate the arbitrary functions to form the differential equation of a given function. For this, let us take a simple example here. The first problem of this, z is equal to x plus y into phi of x square minus y square. This is the given equation which contains a arbitrary function phi. You have to eliminate this arbitrary function phi and then you have to form a differential equation. Eliminate means you have to find the values of the arbitrary function in terms of derivatives, and then you replace that value in the given equation, and that will lead to the partial differential equation. For this here, if I differentiate with respect to x, this is dou z by dou x, which is equal to, here it is a product rule, x plus y into phi of x square minus y square. We keep the function x plus y as it is as a first function into differentiation of the second function. Differentiation of phi of x square minus y square means this is phi dash, this is a x square minus y square into the inner differentiation x square minus y square with respect to x, that is 2x, plus we keep it the second function as it is as a product rule, x square minus y square into differentiation of the first function x plus y with respect to x, it is 1. And now we call this as equation number 1. The same way we're going to differentiate with respect to y. It's a dou z by dou y, which is equal to, the same way here also it is a product of the two functions here. It's an x plus y, we keep it as it is. And differentiation of phi means it is phi dash of x square minus y square into minus 2y into minus 2y, sorry, minus 2y here, plus phi of the second function phi of x square minus y square into the differentiation of y is 1. Now see that, and we call it as equation number 2. By using these two equations, we have to eliminate the arbitrary function phi of x square minus y square, and we form the relation with only the partial derivatives and the variables. For this here, let us say one relation here. Multiply the equation 1 with, here see that here you have to cancel this, means here if I multiply this with y and this with x, here 1 into x plus 2 into here see that here 2 into, sorry, 1 into y and 2 into x. And if I add these two things here, let us write the first equations here. The first, it is the equation number 1 into y means here y into dou z by dou x, which is equal to here it is phi dash, this is 2xy 2xy into x plus y into phi dash of x square minus y square plus it's a y into phi of x square minus y square. And the second equation is x into dou z by dou y, which is equal to, here it is a minus 2xy into x plus y into phi dash of x square minus y square plus this is x into phi of this is x square minus phi of x square minus y square. Now if I add these two, this will be gets cancelled here. You have it is y into dou z by dou x plus x into dou z by dou y, which is equal to, here I can say here x plus y into phi of x square minus y square, because in both the terms we have it's an a phi of x square minus y square. We can take the common factor. I can say it is x plus y into phi of x square minus y square. But for this here, see that this is, you know that in the equation I can write this one as x plus y into phi of x square minus y square can be written as z here. That if I replace it, this is the y into dou z by dou x plus x into dou z by dou y, which is equal to z. And this is our required partial differential equation after elimination of arbitrary function phi of x square minus y square. This can also be written in terms of the notations here, y into p plus x into q is equal to z. This will also represents the partial differential equation. Let us say here also there is no proper the step-by-step process. You have to eliminate the function, given arbitrary function, by using a valid mathematical operations. Then only you will going to get the partial differential equation. Let us take one more equation, the second one, the problem number 2. Let us we say here z is equal to e to the power of my into phi of x minus y. Here also m is some constant is there, but we are not bothering about m, but we are bothering only in terms of phi of x minus y. Phi you have to eliminate, that's an arbitrary function. For that also, you just differentiate dou z by dou x. When you are differentiating with respect to x, y is a constant, m is also constant. You can keep it as it is, e to the power of m into y. The differentiation of the phi is phi dash of x minus y into 1. Same way, this is, you say it is dou z by dou y, which is equal to e to the power of my into m, because in both the terms you have the y terms, therefore you have to use a product rule. Differentiation of the first function into the second function plus e to the power of my first function into differentiation of the second function phi dash of x minus y into inner differentiation is minus 1. Now see that here it is a quite easy way to eliminate the phi. Dou z by dou y, which is equal to m into e to the power of my phi of x minus y, and here it is minus e to the power of my into phi dash of x minus y. Now, see these two terms. This is the one term I can replace it by z. This is z. And this is the one term I can replace it by the first here. This is the one e to the power of my phi dash of x minus y can be replaced it by dou z by dou x. Then I can write the equation as here dou z by dou y, which is equal to m into z minus dou z by dou x. This is our partial differential equation with respect to a given function or a given equation which contains the arbitrary function. The same way, we take one more problem in that. Here it is the problem number 3 here. For this here, let us take a little bit of complicated one here. Let us say z is equal to y square plus 2 into f of 1 by x plus log y. Here you have to eliminate this arbitrary function f. For this, once again the same rule here. First you try to find out the partial derivatives dou z by dou x, which is nothing but it is a y, which will be a 0 because we are differentiating with respect to x, plus 2 into the differentiation of this f means this is a f dash of 1 by x plus log y into the inner differentiation with respect to x is minus 1 by x square, because differentiation of 1 by x is minus 1 by x square. And here this is dou z by dou x will be equal to minus 2 by x square into f dash of 1 by x plus log y. You can call this as equation number 1. Next, you differentiate with respect to y. Dou z by dou y, which is equal to, it is a 2y plus 2 into, this is a f dash of 1 by x plus this is log y into the inner differentiation. 1 by x is 0, for a log y it is 1 by y. Now you see that from the, you call this as an equation number 2, and from these two I will try to eliminate this function. For this, see dou z by dou y, which is equal to 2y plus 2 by y into, see, whenever you have, see that this is the one from this equation, I can write the value of f dash of 1 by x plus log y can be written in terms of dou z by dou x and this 2 by x square. Instead of these things here, f dash of 1 by x plus log y, I can write this will be in terms of, I'll write it in a red only, it is the minus x square by 2 into dou z by dou x. Because of this equation number 1, in place of this, I am writing this. Then I can say here this 2 and 2 will get cancelled here. Just I'll change the color. This is this 2 and 2 will get cancelled. We have here, it's a dou z by dou y. Dou z by dou y will be equal to 2y. It's a 2y. I think it is a minus sign here. Minus x square by y. Minus x square by y into dou z by dou x. into dou z by dou x. Or I can transfer this to this side, or first of all it is a dou z by dou y, which is equal to, if I write this, it is 2y square minus x square into dou z by dou x, and this is y here. Just what I have done is multiply y throughout this equation. Then I can say here y into dou z by dou y. This term I will transfer it to this side, plus this is x square into dou z by dou x, which is equal to 2y square. Or I can write y into q plus x square into p, which is equal to 2y square. This is what the partial differential equation with respect to the given function or a given equation which contains the arbitrary constants. Now, let us take a much more. We have the only one arbitrary function as of now. We go ahead with the more arbitrary functions. In that direction, we take a one more problem in that here. It will be the fourth one here. Let us take it as the problem of, I can say that f of z is equal to f of x plus at plus g of x minus at. Here you have a two arbitrary functions f and g. You have to eliminate both of them. Here the variables are, the z is a dependent variable, x and t are the independent variables. Therefore, let us differentiate first. It is dou z by dou x, which is nothing but f dash of x plus at into differentiation. The inner differentiation is 1, plus this is g dash of x minus at into the inner differentiation is 1. Same way you differentiate with respect to t. This is dou z by dou t, which is nothing but this is a f dash of x plus at into differentiation with respect to t means this is a, plus this is g dash of x minus at into it is a minus a. Now from these two equations, it is not possible to eliminate both the functions f dash. Therefore, what I will do is, I will once again differentiate it. This is dou square z by dou x square, which is equal to, this is a f double dash of x plus at into 1 plus g double dash of x minus at into 1. You call this as equation number 1. Same way, the second order differentiation, dou square z by dou t square, which is equal to, if I differentiate once again, this is a f double dash of x plus at into, already one a is there. Once again, if I differentiate, it becomes a square, because one more term of a it will comes. Plus this is g double dash of x minus at into, this is minus a the whole square. Once again, minus a will come after differentiating the x minus at. Now this can be written here. This is a square f double dash of x plus at plus g double dash of x minus at. Now you call it as equation number 2. From 1 and 2, I can able to eliminate both the arbitrary functions just by substituting the values. See that for this here, I can substitute it this in the equation number 2. Then I can write it as, it's a dou square z by dou t square. will be equal to a square into dou square z by dou x square. Or I can say it is this will be PQ in terms of PQ or ST also. In that you can also represent it dou square Z by dou T square can be written as in terms of it's a don't confuse with the T here because already the independent variable T is there, therefore you keep it as it is. This is the one of the important equation. It's a partial differential equation of the given function. The same way in the assignment, you have a plenty of problems. You try to solve the question numbers 18, 19, 20, 21, 24, 24 and 29 as as an assignment. Just watch this video and try to solve this. And this is the second lecture of the partial differential equation, where the formation of PDE by eliminating the arbitrary functions. And whenever you get a doubt, you please contact the any of the mathematics teachers. Okay, thank you.